Hello. So this is a chapter test on integrals. So won't you, yeah, so welcome to the chapter test on integrals. This is part one. So let's do some problems involving integrals. So let's start with question one. The table of values of a decreasing function is shown. Use the table to estimate the integrals from 0 to 6 of f of x d of x using three equal sub excuse me, using three equal subintervals to find A, right endpoints, B, left endpoints, and C, midpoints, and D, trapezoidal approximation, and determine whether the right and left endpoints are less than or greater than the exact value of the integral. So we're most likely going to do, on this one, we're probably going to do Riemann sums because Riemann sums are uh, two methods, right endpoints, left endpoints, midpoints, and trapezoidal. And here we have a table, right? This was given. Uh, X is 0, 1, 2, 3, 4, 5, 6. Y's or f of x is 0, 9, 8, 6, 2, -7, -9. So what I would do is find delta x. Yes, so step one, before I find the right and the left side, I'm going to find the delta x. So step one, find delta x. And delta x is b minus a all over n. Yeah, n. So my b is 6. It's the last x value. Minus my a is your first x value. And then my n is 3. Yes, it is definitely 3. I mean, this is h, the height. So the height is 3. Okay, so that's going to be 6 minus 3 over 2. Okay, so now we can find the right endpoints. So the right endpoints is going to be delta x. And what we're going to do is, actually what I should have done is draw like a little, should have drawn a little rectangle. So ours, let's see, we're going from 0 to 6, right? So if you want to draw it, you should. It looks something like this. So we're going on the right endpoint. Here's 2, 4, and 6. Okay, so part A for the right. So when we take the area of the rectangle on the right side, it's going to be delta x equals f of x naught plus f of x1 plus dot 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 f of xn. And we just plug in what we know. So delta x was, we found that was 2. So we're going on the right. So the first one would be what is the height when your x value is 2 plus what is your height when your x value is 4 plus what is your height when x is 6. So this is going to be 2 And then what's f of 2? You can look at your chart. F of 2 spits out 8. That's the height, right? F of 4 spits out a y value of 2, or a height of 2. And then f of 6 spits out or has a height of -9. So when you put it all together, this is going to be 2 times 1, which is 2. Okay. Now let's do part B. Let's find the Riemann, find it using the left side approach. So it's still delta x, which is 2. The only thing is we're going from the left. So now we're going to use 0 and then 2 and then 4. Okay. That's the only difference. So it's going to be f of 0 plus f of 2 plus f of 4. So this is going to be 2, and then f of 0 spits out 0. F of 2 spits out 8. F of 4 spits out 2. So that's 2, and then 0 plus 8 plus 2 is 10. Wait, f of 0. Yeah, I was just double checking. F of 0 is definitely um, 0. So yeah, this is going to be 20. Okay. Now let's do the midpoints. So let's kind of redraw this. We're going from the midpoint. So here's trapezoid. It's going to be 2, 4, and 6. Okay, so the midpoint is, so here's 0. We're going halfway point. So the midpoint from 0 to 2 is 1. The midpoint from 2 to 4 is 3. The midpoint from 4 to 6 is 5. Okay, so that's going to be delta x, which is 2. And then we're going to find f of 1 plus f of 3 plus f of 5. Okay, and put it all together. This is f of 1 is 9. Wait, f of 1, let me double check. Yes, f of 1 is 9. You just look at the chart. And then f of 3 spits out 6, and then f of 5 spits out -7. This is going to be 2, and then 9 plus 6 plus -7 is 8, and then 2 times 8 is 16. Okay, so that was the midpoint rule. Now let's do trapezoid. So in trapezoid, if you kind of drew it a bit, it would look something like this. So you make little tiny trapezoids like that. So in a trapezoid, it's going to be 1/2 times the delta x times f of 0 plus, so the area of a trapezoid is base. You add up all the bases divided by 2, right? So it's going to be, this is going to be plus 2, and then f of 2 plus f of 4, and then plus f of 6. So this is going to be 1/2, and then the delta x is 2, and f of 0 is 10 plus 2. So it's 2 times f of 2 plus f of 4. So f of 2 is 8, and then f of 4 is 2. And then f of 6 is -9. Put it all together, you get 1/2 times 2 cancels, and then you're left with 10 plus 2, and then 8 plus 2 is 10 plus -9. And that gives us 2 times 10 is 20 plus -9. Put it all together, you get 21. Okay, we did all that, and then the last part of the question says, it says, and determine whether the right and left endpoints are less than or greater than exact values of the integral. So if you kind of look at it again, here's 0, here's 2, here's 4, and here's 6. If you drew your rectangles, it would look like this. Right? And then we're going to make it go from the left. So this is the left side, and I believe it is, you have this leftover, so it is technically above. And I'm going to say it's a greater estimation. You have a little bit extra, so it's going to be definitely a greater estimation. Okay, so that was the left, so that's definitely above or greater than, and then the right would look something like this. So it would look, this would be the right. And yeah, you have, wait, so keep it, this is the left, right? And then the right is here. So it looks like you have a less than or an underestimate. Okay, so that was a review of Riemann sum. So with Riemann sums, you can do right, left, midpoint, and trapezoid. And we said that left, if you do the left side, it's a greater estimation. And if you do the right, it's most likely an underestimate. What would be the perfect one? I think it would be the trapezoid. I think that's more closely to exact. Okay, so let's move on to example 2, question 2. Number 2 says the graph of a function f of x consists of two straight lines and a semicircle. Estimate from the integrals 0 to 8 f of x d of x using four subintervals with A, right endpoints, B, left endpoints, C, evaluate the integral. So here we have this graph, right? We're supposed to find the right endpoints, the left endpoints, and then evaluate the integral. So we have to do Riemann sum. So here's our graph. So what I'm going to do first is find my delta x. My delta x is b minus a all over h. My b is 8, the largest. My a is a starting point that's 0, and my height is 4. So that's going to give you 8 over 4, which is 2. And if you want to draw it a little rectangles, that's fine. Okay, so 0, 2, 4, 6, and 8. So let's do the right. So the right is the delta x, which is 2. And then I believe we're going to plug in the height of, because remember, I forgot to ask, we're basically taking the area of these rectangles, and the area of rectangle is length times width. So the length is 2, right? Going increments by 2. This is why I factor out a 2. And then we got to find the height. So on the right, it's going to be f of 2, f of 4, f of 6, and f of 8. So that is going to be 2, and then f of 2, you just look at the graph, f of 2 spits out a y value of 0. F of 4 spits out a y value of negative 2. F of 6 spits out a y value of 0. F of 8 spits out a y value of 1. Put it all together, you get 2, and then this negative 2 plus 1, that is negative 1, which spits out negative 2. So on the right end, it's your area or your estimate is negative 2. That could be true, right? Because this is a negative, so you're definitely going to have a negative area. Okay, let's do part B. So now we are doing the left-hand side. So the height, the length is still 2. The height, it will be different. So now we're going on the left. So this time we're going to find f of 0 plus f of 2, right? Plus f of 4 plus f of 6. So that's 2, and then f of 0 is 4. F of 2 is 0. F of 4, whoops, it was an f of 4 spits out negative 2. And then f of 6 spits out 0 as well. And then 4 plus 0 plus negative 2 is positive 2 equals to 4. Okay, let's move on to letter C. So now we got to find letter C. Evaluate the integral. So basically, you just add up all the shapes. So from the integral from 0 to 8 of f of x d of x is going to be, so look at your graph. You basically find the area. You know how you got to find the area of this shape, and then this shape or this triangle. So this forms a triangle. This forms like half a circle, and then this also forms a triangle, right? And we know how to find the area of all those shapes, right? So we have a triangle, half a circle, plus another triangle. So we know the area of a triangle is 1/2 base times height. We know that the area of a circle, or half a circle, yeah, half a circle is pi r square over 2. And we know that the area of this triangle is also 1/2 base times height. Okay, so let's look at the first triangle. What's the base? 0 to 2, that looks like it's 2. What is the height? I believe it spits out 4. And then all over 2. Plus, over here, what is the radius? So from radius is like halfway point, so that's like saying 2, right? From 4 to 6, that's a total of 2. So my height, my radius is 2, so that's going to be 2 squared over 2 plus 1/2. 1/2, and then the base is my base. The base is what's the distance from 6 to 8? 2. And what is the height? It's 1. Okay, put it all together. This is going to be 4 times 2 is 8, divided by 2 is 4, plus 2 squared is 4 pi over 2. 1/2 times 2 is 2. So that's 4 plus 4 pi over 2 is 2 pi plus 2. That's going to be 6 plus 2 pi. Whoops. Why? Okay, I made a mistake. This should be negative. Why? Because if you look at the image, it's going below the x-axis, right? So that's most likely going to be a negative value. So if you're under the x-axis, it's most likely to be a negative value. Okay, so this should be negative 2 pi. There you go. Much better. So that's going to be 5 minus 2 pi. That is going to be negative 1.28. Okay. Okay, let's move on. Now let's actually do some integration rules. So question 1, 2 was all review from Riemann sum, left-hand point, right-hand point, midpoint, and trapezoid. Okay. So let's look at number 3. What is the integration of 2x4 minus 4x squared plus 3x minus 2 of d of x? And it looks like we have no boundaries, so that means we will have to add a plus c. So yeah, this one's not too bad. You can just take the integral of each term. So what is the integration of 2x to the 4? Well, it's nothing fancy. It's old power plus 1, so 4 plus 1 is 5, divided by that power. The same thing with negative 4x squared, nothing fancy. It's just old power plus 1. 2 plus 1 is 3 over 3, plus the integration of 3x. This has a divisible power 1, so 1 plus 1 is 2 over 2. And then the integration of a constant in respect to x, it's going to be negative 2x. And don't forget the plus c. So let's see if we can clean this up. This is still 2 over 5 is the same thing as 2/5. You could put the x in the center or on the top. It's not wrong. So I'm just going to put the x in the center. The same thing here, you could put the x on the top or on the center. But do not put it in the bottom. Okay, there you go. That is your final answer. Not too bad. Just knowing your integration rules. Let's look at example 4. We have to take the integration from the square root of x minus 4 over the fifth root of x of d of x. There's no boundaries, so we're going to have to add that plus c at the very end. So what would I first do? I think I would be, to make life easier, I think I'll rewrite everything in power. In a power. So let's start with square root of x. How can I rewrite square root of x to the power? It's the same thing as x to the 1/2, right? Minus, how can I rewrite 4 over the fifth root of x? Well, I know that the fifth root of x is the same thing as x to the 1/5, but I want to make that x to the 1/5 on the numerator to make your life easier. I don't want that x to the 1/5 on the bottom, so you can rewrite this as x to the 1/2 minus. So to write this x to the 1/5 on the numerator is going to be 4x to the 1/5, and then d of x. Okay. Now we can just take the integration by using your integration rules. So start with x to the 1/2. This is going to be it's old power plus 1, so 1/2 plus 1, or we could use 2 over 2, divided by that power. So what's 1/2 plus 2 over 2? It is 3/2. So that is going to be x to the 3/2 over 3/2. So you get a complex fraction. We can fix that now. But how do if you want, you can rewrite this. So x to the 3/2 is your numerator. 3 over 2 is your denominator. So you can rewrite this as x to the 3/2 over 1 divided by 3 over 2. And then you may cross multiply. So 2 times x is 2x to the 3/2. And then 1 times 3 is 3. Okay, so that's how I simplify that complex fraction. Now let's look at negative 4x to the 1/5. The power, so it's going to be negative 4, and then it's old power plus 1, so 1/5 plus 1, or 5 over 5, divided by 1/5 plus 5 over 5 is 6/5. So let's clean that up right now. So this is going to be negative 4x. 1/5 plus 5 over 5 is 6/5, divided by 6 over 5. You have a complex fraction. So this is your numerator, and this is your denominator. So we can rewrite this as negative 4x to the 6/5 divided by 6 over 5. Cross multiply, so that will be negative 24x to the 6/5 over 6. And we know that negative 24 over 6 comes out nicely as negative 4. Whoops, did I make a mistake? I think I made a mistake somewhere. Let's see. Yeah, might be the mistake I made. This is supposed to be not a positive 1/5, but a negative 1/5, right? Because the x to the 1/5 is on the bottom. So yeah, that completely changes everything. Okay, so this is going to be negative 4x, and then negative 1/5 plus 5 over 5 is 4/5, divided by not 6/5, but 4/5. So you're going to rewrite this as negative 4x to the 4/5 divided by 4/5. Go ahead and cross multiply, so that is going to be negative 20x to the 4/5. And then 1 times 4 is 4. Negative 20 divided by 4 is negative 5. There you go. Much better. this is going to be negative 5x to the 4/5. And then don't forget the plus c because we have no boundaries. Now, sometimes you can simplify this. You can rewrite, we have it in power, so we can write this in radical form. So 2x to the 3/2 can also be expressed as 2/3. So x to the 3/2 is the same thing as the square root of x cubed minus 5x to the 4/5. That's the same thing as negative 5 of the 5th root of x4. And then don't forget the plus c. Okay, let's move on to the next one. So we have the integral of 1 plus 3 sine of x minus 5 cosine of 2x of d of x. So there's nothing too special. There's no boundary, so we do have to do a plus c. So we could just take the integral individually. So what's the integral of 1 in respect to x? Yes, x. What's the integral of 3 sine of x? Well, remember, if you have a constant, you can take it out and just take the integration of sine of x, which is negative cosine of x. What is the integration of negative 5 cosine of 2x? Well, negative 5 is a constant, so you can take it out. And then what is the integration of cosine of 2x? It is the integration of cosine of x is positive sine, and then it's still going to be 2x. And then you divide it by whatever inside of here. So that's just our the 2. So this 2 stays at the bottom. So basically you divide coefficient by the angle. So you divide by coefficient of the angle. Okay? So if this was a 3x, you're going to divide it by 3. If it was a 5x, you're going to divide it by 5. Now, okay. And then don't forget the plus c. So you're going to get x, and then 3 times negative is negative 3 cosine of x. And then this is going to be negative 5/2 sin 2x. Let's see. Okay, so that's one way of doing it. The other way is you can just take it, the integration separately, one by one. That's perfectly fine. And then for this one, you could also use what's called U substitution. So I'll show you really briefly. So break it into how many integral parts? 1, 2, 3, 3 integrals. So you can rewrite this as integration of 1 of dx plus the integration of 3 sin of x d of x plus the integration of negative 5 cosine of 2x d of x, right? So let's look here. What's the integration of 1 d of x in respect to x? X. What over here, you have this 3, you could just bring it in front of the integral. And then what's the integration of sine of x? Yes, it's negative cosine of x. And then don't forget to multiply this by 3. Over here, you have a constant of negative 5, so you could put that in front of the integral. Now, the other way you could do this for the cosine of 2x, if it was cosine of regular x, you could have just, it would have been sine of x, right? The integration of cosine of x is sine of x. But because we have a 2x, this is more the longer way. You can use what's called the U sub, if that makes it more comfortable. So your U is going to be the 2x. And then you take your du, which is 2 dx. And then you'll have to get rid of this 2 because there's we don't have an extra 2 near the cosine, so get rid of it by multiplying both sides by 1/2. So this is going to be 1/2 du, and then this is going to be 2 times 1/2 is dx. So you can rewrite this as cosine of 2x, which is u. And then you're going to replace d of x with 1/2 du. Okay. Then you have this 1/2, which is a constant. So you could bring that 1/2 in front of the -1, in front of the -5, so that would be -5/2. Just going to be cosine of u du. And what is the integration of cosine of u? It is sine of u. And then you have this, don't forget to bring out -5/2. So if you put it all together, this is going to be 3 minus 3 cosine of x. And then it's going to be -5/2 sine. And then you must replace your u with 2x. Don't forget the plus c. Okay. If I go too fast, you can always pause and rewind the video. Okay, let's move on to example question 6. So question 6, we have the integration of 5 plus x cubed over square root of x d of x. So we're dealing with radicals, so what we can do is, let's rewrite everything in terms of power. So this is going to be 5 plus x cubed all over. The square root of x is also the same thing as x to the 1/2 of d of x. Now what you're doing is you're literally dividing each term by x to the 1/2. So this 5 is divided by x to the 1/2 plus, and then you're dividing the x cubed by x to the 1/2. And then you have the dx. Okay, let's clean this up. So 5 over x to the 1/2, I want that as a negative power because I want it on the top. So this 1 over x to the 1/2 is the same thing as x to the -1/2. And then you have a 5 plus, what is x3 divided by x to the 1/2? Well, remember when you're dividing with the same base, what do you do with the exponents? Yes, you subtract them, right? So it's really 3 to the 1/2. LCD is 2, so multiply this top and bottom by 2, so that's 6. So 6 minus 1 is 5/2. So this is going to be x to the 5/2. And then you have this dx. And now we can just take the integration by using your power rule, your integration rule. So what's the integration of 5x to the -1/2? Well, that's going to be 5x and then old power plus 1, so -1/2 plus 1, or 2 over 2, over that power. So -1/2 plus 2 over 2 is +1/2, which is 5x. -1/2 plus 2 over 2 is 1/2 divided by 1/2. So that's going to be 5x to the 1/2 divided by 1 over 2. And then this is going to be cross multiplied, so 5x to the 1/2 times 2 is 10x to the 1/2, and then 1 times 1 is 1. So that's going to be 10x to the 1/2. And then what's the integration of x to the 5/2? So that's not too bad. It's just old power plus 1. So 5/2 plus 1, or 1 can be expressed as 2 over 2. So that's going to be x to the 7/2 divided by 7 over 2, right? So it's going to be x to the 7/2 divided by 7 over 2. And then cross multiply, so that's going to be 2x to the 7/2 over 7. So your final answer is going to be 7x to the 7/2. And then because we have no boundaries, you do have to add that plus c. So this is one way of expressing it. What is the, okay, so this is one way. If you want to write it as a power, that's perfectly fine. Sometimes your teacher wants it in a radical form, so you can also write this as 10x to the 1/2 is also 10 square root of x plus 2/7 x to the 7/2 is like the same thing as 2/7 square root of x to the 7 plus c. Okay, let's move on to 7. Okay, so we have the integration of 3x minus 8 secant squared of x plus sin of 4 of x d of x. So we could just take the integration of each term, right? So what's the integration of 3x? Well, it's just power rule, right? Old power plus 1, so 1 plus 1 is 2, divided by that power. What is the integration of negative 8 secant squared of x? Well, negative 8 is a constant, so you may take it out or factor it. And what is the integration of secant square of x? That's a special integration rule or a trig integration, and that's going to turn out to be tan of x. Okay, plus, what's this integration of sin of 4 of x? So you can do the shortcut. You don't have to do the u substitution. What is the integration of sine? It's negative cosine. Leave the parentheses alone. And then you divide it by the coefficient of x. So the coefficient is 4. You divide it by 4. And then don't forget the plus c. So when you put it all together, you're going to get 3/2 x squared minus 8 tan of x. And then this is like an invisible negative one, so you can rewrite this as negative 1/4 cosine of 4x. Let's see. Okay, good. Any questions? I mean, there's a lot in there. Okay, let's move on to question 8. So question 8 is now we have boundaries. Our lower boundary is 1 and our upper boundary is 2. And we got to take the integration of x cubed minus 4x minus 1 of d of x. So this is not too bad. You could just take the integration of each term. What's the integration of x cubed? It is old power plus 1, so 3 plus 1 is 4, divided by 4. What's the integration of negative 4x? This has a power of 1, so negative 4x, and then 1 plus 1 is 2, divided by 2, which is going to be negative 2x squared. What is the integration of negative 1 in respect to x? Is going to be negative x. Okay, and then you may apply the upper and the lower. So my lower boundary is 1 and my upper boundary is 2. So do the upper minus lower. So it's going to be 2 to the 4th over 4 minus 2 and then 2 square minus 2. And then it's going to be minus, and then you're going to apply the bracket, and then you apply the lower boundary. So this is going to be 1 to the 4th over 4 minus 2 times 1 square minus 1. Two to the 4th is 16 minus 2 squares 4 times negative 2, negative 8 minus 2 minus bracket 1 to the 4th is 1/4 minus 1 squared is 1 times by 2, that's negative 2 minus 1. 16 divided by 4 is 4 minus 8 minus 2 minus 1/4. Negative 2 minus 1 is negative 3. So this is going to be 4 minus 8 minus 2 is negative 6 minus bracket 1/4 minus 3. You know how to do that. LCD is 4, so multiply this talking about 4. 3 times 4 is negative 12. 1 minus 12 is negative 11. over 4. And then over here, two negatives become the positive, so that's positive 11 over 4. And then you have a minus 6. And then you know how to add fractions, so this has a denominator 1. What is LCD? 1 and 4 is 4, so multiply the top and bottom by 4. That's negative 24. And then negative 24 plus 11 is negative 13. Yeah, not too bad. The only difference is we did not apply fundamental. We did we did apply the fundamental. We didn't, because we have boundaries now. We did the upper minus the lower. Let's move on to number 9. And so number 9, we have the square integration of 1 to 4, x squared minus x plus 1 all over square root of x. So first step is rewrite everything in power form. So this is going to be, let's see, or we could just, so square root of x is the same thing as x to the 1/2. So just divide each term by x to the 1/2, right? So this is going to be x squared over x to the 1/2 minus negative x over x to the 1/2. Just write it out for right now. Plus 1, so divide everything by x to the 1/2. So this is 1 over x to the 1/2 dx. And this is going to be 1 to the 4. X2 over x to the 1/2. We remember when you're dividing with the same base, you subtract. So what's 2 minus 1/2? That will be 4 minus 1 is 3/2. This is going to be x to the 3/2 minus, what's x1 over 1/2? So you're subtracting power, so it's 1 minus 1/2, which is 2 over 2. So 2 minus 1 is 1/2. That's x to the 1/2. 1 over x to the 1/2. Let's rewrite that as a negative power. So 1 over x to the 1/2 is the same thing as x to the negative 1/2, right? Okay, and then you just take your integration rule. So what's the integration of x to the 3/2? Well, it's whole power plus 1, so 3/2 plus 1, which is x to the 5/2 divided by 5 over 2, minus, what's x to the 1/2? Whole power plus 1, so 1/2 plus 1, or 2 over 2, divided by that power. 1/2 plus 2 over 2 is 3/2, so that would be x to the 3/2 divided by 3/2. And that should give you negative 2/3 x to the 3/2, right? What is the integration of x to the negative 1/2? So that's going to be whole power plus 1. So negative 1/2 plus 2 over 2 is 1/2. So that's going to be x to the 1/2 divided by 1/2. Okay, this I'm not going to show. You should know how to simplify complex fraction. That simplifies as 2/5 x to the 5/2. This is going to be negative 2/3 x to the 3/2. And then this is also a complex fraction, and that simplifies as plus 2x to the 1/2. And then you may apply the fundamental theorem because we have boundaries, right? So do the lower and the upper. This is 1, and then this is 4. So apply the upper minus lower. So this is going to be 2/5, and then this is going to be 4 to the 5/2 minus 2/3, and then this is going to be 4 to the 3/2 plus 2 times 4 to the 1/2 minus bracket. And then you may do the lower, so replace your x with 1. So this is going to be 2/5 of 1 to the 5/2 minus 2/3 of 1 to the 3/2 plus 2, 1 to the 1/2. And I will save you time. Okay, so if you want, what you could do is maybe rewrite 4. You could put all this in the calculator. Yeah, you could put this all in the calculator, but if you want, you can rewrite 4 as a base of 2. So this is going to be 2 squared to the 5/2 minus 2/3. Same thing with 4. This could be written as 2 squared to the 3/2 plus 2, and then 4 could be expressed as 2 squared to the 1/2 minus, this is not too bad, 1 to the 5/2. 1 to the 5/2 is 1 times by 2/5. That's 2/5. 1 to the 3/2 times negative 2/3 is negative 2/3. 1 to the 1/2 is 1 times by 2. And then when you put all this in the calculator, you should get, I'm going to save you time because you should know how to do this. This should give you, your final answer should be 146/15. Okay, so it cannot be reduced. That is your final answer. Okay, let's move on to number 10. Okay, number 10, we have to take the integration from pi6 over pi3 of sine theta plus 1 plus cosine squared theta all over 1 minus sine squared theta. So what do we know? What do we know? Is there an identity we can use? Yes. You can use one of your Pythagorean identities. 1 minus sine square theta is the same thing as cosine square theta. And then what else? Maybe I'll just leave the top alone right now. Then what I would do next is divide each term by cosine squared theta. So yeah, divide each term by cosine squared theta. So this will be sine theta over cosine squared theta. So it's going to be plus 1 over cosine squared theta is 1 over cosine squared theta plus cosine squared theta over cosine squared theta. It's just going to be d theta. Okay. Let's see here. So we know that this just becomes 1. So when you simplify this, this is going to be simplified as sine theta over cosine theta times cosine theta. And you get, so now you can just, how I would do this is use your trig rule. So you're dividing, you could break this down into 2 things. This is a sine theta over cosine theta. This has invisible 1. So that is going to be pi over 6 over pi over 3. So sine theta over cosine theta, that's the same thing as tan theta, right? And then times 1 over cosine theta 1 over cosine theta is the same thing as secant theta. And then plus and then this is going to be plus, okay, so let's see. So this is going to be sine theta plus 1 is cosine squared theta. So and then don't forget you have a secant square theta. Yeah, you have an extra secant square theta. And then don't forget you have this plus 1 here. Now you have this. And then if you want to rearrange it, you can rewrite. I guess you could put the secant first, so you could be like secant theta times tan theta plus secant square theta plus 1 d theta. Okay, so let's take, what is the integration? We could take the integration in terms. What is the integration of secant theta times tan theta? Uh, I believe it's going to be secant theta. And then what's the integration of secant square theta? That is a trig integral. That is going to be tan of theta. And then what's the integration of 1 in respect to theta? It's just theta. And then you just do the lower minus the upper. And you get, so put in the pi over 3. So secant of pi over 3 plus tan of pi over 3 plus pi over 3 minus bracket, and then do the lower boundary secant of pi over 6 plus tan of pi over 6 plus pi over 6 and so what is the secant of pi over 3? So if here's your unit circle, let's see, here's pi over 6, which has an x coordinate of radical 3 over 2 and a y coordinate of 1/2. And then here's pi over 3. It has an x coordinate of 1/2 and a y value of radical 3 over 2. So the secant is the reciprocal of cosine. So secant of pi over 3, here's pi over 3, it's the reciprocal of cosine. So if cosine is 1/2, the reciprocal of that would be 2. Plus tan of pi over 3, here's pi over 3, the tan is the y over x. So that's radical 3 over 2 over 1/2. Plus pi over 3 minus secant of pi over 6 is, here's pi over 6, secant is the reciprocal of cosine, which is 2 over radical 3, plus tan of pi over 6. The tan of pi over 6 is the y over x. That's 1/2 divided by radical 3 over 2, plus pi over 6. Okay, so if you clean this up a little bit more, so this is going to be 2 plus, over here we have a complex fraction, the 2's cancels, you're just left with radical 3 plus pi over 3 minus 2 over radical 3. So here the 2's cancel, so you're just left with 2 over square root of 3 plus 1 over radical 3 plus pi over 6. And put it all together. Is this. You can collect this, so that would be 3 radical 3 plus pi over 6. So yeah, I guess you can clean this up. So when you clean this all up, you should get, to save us time, the final answer should be 12 plus pi over 6. When you add them all up, collect like terms, make sure the denominators are the same, you should get 12 plus pi over 6. Okay, let's move on. So on number 11, it's the integration from 0 to 2 of parentheses x squared minus the absolute value of x minus 1 of d of x. So what we can do is I would break it down into two separate integration. So it's going to be from 0 to 2 of x squared dx minus the integration from 0 to 2, and then it's the absolute value of x minus 1 of dx. So I just split it into two separate integrals. This absolute value is really confusing. What you could do is draw it a bit. Maybe that would help. So what does the absolute value of x minus 1 look like? It's an absolute value graph, but it has a horizontal shift of 1 unit to the right. So it should look something like this. Here's 1. And we're only going from 0 to 2. So it's going to be in this area. And let's pretend this is 2. Okay. So what is the integration of x squared? That's like, it's going to be x cubed over 3. And then I guess we could do the bounded. We could do the fundamental. So it'd be 0 to 2. And then it's going to be minus. So this one, how do we take the integration of this? So this is the absolute value. What do you see? I see two triangles. And how do you find the area of a triangle? You kind of have to use base times height over 2, right? So you're going to use some geometry. So if we look at this triangle, let's call this triangle 1. What is the area of that? So it's going to be the base. It's going to be 1/2 times the base. So the distance from 0 to 1 is 1. And the height is also 1. Right? If you plug in yeah, the height is also 1. Plus, and then if you look at this triangle, it's going to be 1/2, and then the base is also 1, and the height is also 1. So what is 1/2 times 1 times 1? That is 1/2. What's the plus? What's 1/2 times 1? What's 1/2 times 1 times 1? That's also 1/2. And that would be 2 over 2, which is 1. So on this one, we didn't have to, this is 1. This one, we didn't have to apply fundamental. I just took the area of the two shapes, and you should be good. Here we got to do the fundamental. So upper minus lower, so it's going to be 2 cubed over 3 minus 0 cubed over 3. So 2 cubed is 248 minus 0. 8/3, 8/3 minus 1. 1 is the same thing as 3 over 3. So 8 minus 3 is 5. So your final answer is 5/3. Okay, so if you're dealing with absolute value, maybe it's better just to draw it and then take the area from there. Okay, let's do one more for this part one. So number 12, what is the integration from 2 to 4 of x over x squared minus 1 squared dx? So this one you must do use substitution. You cannot divide each term by it. I would not FOIL this out and then divide each term by that. It would be so confusing. So I think I'll just use u substitution. And my u is going to be x squared minus 1. Then you take your du. What's the derivative of x squared? It's 2x. What's the derivative of negative 1? 0. And then you have to add this dx. Now, is there anything we need to must get rid of? Well, we have an x. We have a dx, which is good for here, but we don't have this extra 2. So what you're going to have to do is get rid of that 2 by multiplying by the reciprocal 2, which is 1/2. You're going to multiply both sides by 1/2. So this is going to be 1/2 du. And then 2 times 1/2 is just x dx. So this works out nice. So you're going to rewrite this problem as the integration from 2 to 4. You're going to replace x squared minus 1 with u. And it still has the power of 2, so put 2. And then you may, do you see this x in the dx? You may replace it with 1/2 du. Okay. Then what you would do is continue. This is 1/2, which is a constant, so you may take that out and then put a 2 here and a 4. And now you have 1 over u squared du. Okay, what is the integration of 1 over u squared? Please do not say u ln of absolute value u. It would have worked if it was 1 over u, but it's not. So what I'm going to do is rewrite this as negative power. So 1 over u squared is the same thing as u to the negative 2. And then you have a du. And then what is the integration of u to the negative 1? So just negative 2 plus 1 over negative 1. So that's u, and then negative 2 plus 1 is negative 1 for negative u. U to the negative 1 is 1 over u, and then you have this negative 1. It's going to be negative 1/2, 1 over u times it by 1/2. So that's going to be negative 1 over 2u. And then you do the lower and upper. So that's going to be negative 1/2 u, and then 4 minus 2. So when you put this all together, you're going to get, you should get 4 over 30, right? Negative 1/8 minus 1/4. But what did I do? Did I do anything wrong? Yeah, you should somehow get 4 over 30, and this may reduce by, maybe reduced by 2. So now your answer is 2 over 15. Okay, so that is your answer. So this is part one of integral exam. There will be another part, so I'm going to stop here.